Hey students, in this third example formulating systems of linear and quadratic equations, we are going to talk about a problem that talks about a soccer ball being kicked over a hill. So the graph shows the height of y in feet of the soccer ball and the x seconds after it is kicked from the base of a hill with an initial velocity of 30 feet per second. Keyword right there, as soon as you see initial velocity, keep that in mind that is going to be probably used in that special equation that we mentioned for gravity. So initial velocity, that's 30. And then the linear function represents a hill with a constant slope. After how many seconds does the soccer ball land on the hill? So they're asking you for this specific intersection when it lands on the hill. Now, when they give you velocity, they most likely give you the initial height as well. The fact that it says that it's kicked from the base of a hill, that means that it's starting at 0. So here in the graph, it's super obvious that it's at 0, which is also keywords there, base of the hill. So that means we're going to use 0 as the initial height. So the equation we're going to use is the negative 16x squared plus initial velocity x plus initial height. We're going to substitute the value of initial velocity and initial height in our formula, or our equation, sorry. Negative 16x squared plus the velocity is 30, so 30x plus the the height is 0, so 0. But in an equation, we really don't need a value there if it's just 0. So our final equation for quadratic parabola right here is negative 16x squared plus 30x. So we're going to use this equation when we graph the quadratic parabola. Next, we need to create that linear function created by the hill. So we're going to use our Algebra 1 skills for this. We're going to recall that a linear equation is written as mx plus b, y equals mx plus b, where we only need to substitute the slope and the y-intercept. So the y-intercept can be found by looking at the graph, or also just considering that it's the initial or starting value. And it also pretty much says that the hill is where it's starting, right? Like right here. So we're going to use 0 as our v value. The slope, the way we can find slope is in 3 different ways. The slope based on Algebra 1 level, they teach you to calculate it. y2 minus y1 over x2 minus x1. Or if you have a table, you can also just consider looking at the change of y over change of x. Or you can also just find it in a graph as rise over run ratio. But the formula always works. So we can pretty much conclude this as saying the difference between the y's over the difference between the x's. Here in this graph, we can see that our points for the line are going to be 0, 0. So we can make a mini table of 0, 0, and then the other point will be right here at 2, 2. And the difference between our y's is going to be in a plus 2, and the difference between the x's is going to be another plus 2. So the slope, if we find it as difference of y versus difference of x, is just going to be 2 over 2, which simplifies to be a 1. All this work for just the value of 1. That means our slope right here is going to be 1, and then x, and then y equals. So to simplify this equation, it's going to be y equals 1x. So we're going to use the quadratic equation of y equals negative 16x squared plus 30x and the linear equation y equals 1x. Let's go ahead and graph those. So in our calculator, we can use this part as well for graphing. Menu, graph function, and we're going to type the negative 16 x squared plus 30x. Press down, and then now let's type the line. So just 1x. And we're looking for this intersection right here. So we're going to go menu, analyze, intersection, to see where that soccer ball is going to land on the hill. So at 1.181, 1.181, that's our intersection point. So we can label that point right here as 1.81, comma 1.81. But now we need to interpret what that point means. So if the question is asking after how many seconds does the soccer ball land on the hill, we can say that after 1.81 seconds, it's going to land on the hill at 1.81 feet. So just keep that in mind, that this is your seconds and this is your feet. Okay, I hope this video helps with formulating systems.